Good evening everyone. Last time we have seen the inverse Z transform. Okay. Now let us see the analysis of DT system using Z transform. Analysis means DT system is given. Okay. We have to find out its output for any input using Z transform. That is we call the analysis of DT system. Okay. So DT system is given either by its difference equation or by its impulse response. Now let us see the representation of DT system will be like this. Okay, in Z domain, DT system is represented by its transfer function. And this transfer function we know that is a ratio of output variable upon input variable with all initial conditions are 0. Okay, and the output of DT system in Z domain is obtained as y of z is equal to this x of z input into h of z. Okay, this is output equation. Using this output equation we can find out the output of the system for any input if we know the transfer function of the system. Okay, so once more I will tell you, this is the output equation of the to find out the output of the system. This is the output equation, y of z is equal to x of z into h of z. So if we know the input, okay, and if we know the transfer function of the system, we can find out the output of the system. Okay, so if we know the transfer function of the system, we can find out the output of the system for any input. Okay, so in this is a representation in Z domain, that is frequency domain. In time domain, DT system is either represented by the behavior of DT system is either represented by its impulse response or difference equation. Okay, so how does the system is behave? Okay, that is represented by either its impulse response or difference equation. Difference equation gives the relationship between input and output. Okay, and the order of the difference equations will depends upon the order of the system, which in turn depends upon the number of poles of the system, and the number of poles of the system will depends upon the number of energy storage element in the system, like inductor and capacitors. Okay, so if the system is represented by difference equation, then we have to take its Z transform and obtain the transfer function of the system. So if the difference equation is given, system is represented by the difference equation, you have to take the Z transform of difference equation and obtain the ratio y of z upon x of z. This is we call a transfer function. Now once you get the transfer function, we can find out the output of the system for any input by using this equation, y of z is equal to x of z into h of z. Let us say that if you find out the impulse response, what is the impulse response? It is the output of the system for impulse input. So when you apply the impulse input, x of n is equal to del n, whatever may the output of the system, that is we call as the impulse response of the system. Okay, and so if you want to find out the impulse response of the system, we have to keep the input x of n is equal to del n. Okay, so we have to take the input x of n is equal to del n, and therefore the Z transform of this x of del n is what it is, 1. So x of z is equal to 1. Okay, Z transform del n is 1, and therefore you are getting, if you put here x of z is equal to 1, then you are getting y of z is equal to x of z into h of z. X of z is 1, so you are getting y of z is equal to h of z, and h of z already we obtained in this equation. Okay, so put the value of h of z here and get the inverse Z transform, we'll get the impulse response h of n. Okay, to find the step response, you have to change the input. Step response, response means output of the system for step input. Okay, so you have to apply the unit step input u of n as input and find out the output of the system, that is we call as the step response. So while finding the step response, we have to consider the input of the system x of n is equal to u of n, and therefore taking its Z transform, x of z is equal to Z transform u of n is what it is, z upon z minus 1. and therefore in this output equation x of z is replaced by z upon z minus 1, and then here you have to place this h of z, do the partial fraction expansion of this expression, and then take the inverse z transform, find out y of n. This y of n is called as a step response. This is called as a step response of the system. Okay, let us see the problem based on this. If you want to solve the difference equation using z transform, then we should know the formulas. Okay, so these are the formulas. Okay, the z transform y of n plus 1 is equal to zy of z minus zy of 0. Okay, z transform y of n plus 2 is equal to z square y of z minus z square y of 0 minus zy of 1. Z transform y of n plus 3 is this one. Well, this y of 0, y of 1 and y of 2 are we call as the initial condition of the network. Okay, or initial condition of the system. So if the initial conditions are 0, then z transform y of n plus 1 is just zy of z. Z transform y of n plus 2 is z square y of z. And z transform y of n plus 3 is z cube y of z. Okay, so if the initial conditions are 0, then this y of 0, y of 1, y of 2 are 0. Okay, similarly the z, if the difference equation is represented in terms of the difference element, this is we call it a difference element, and this is the advanced element. So z transform y of n minus 1 is equal to z raised to minus 1 y of z plus y of minus 1. Z transform y of n minus 2 is z raised to minus 2 y of z plus z raised to minus 1 y of minus 1 plus y of minus 2. Okay, so these are the formulas. Here again we say that y of minus 1, y of minus 2, y of minus 3 are the initial condition. If it is not given in a problem, assume that the initial conditions are 0. System with initial conditions are 0 are we call as initially relaxed system. Initially relaxed system. For initially relaxed system, the all initial conditions are 0. Okay, so let us see the problem which was asked in May 18. Determine the impulse response of the system described by this difference equation. Okay, so here the initial conditions are not given, and therefore the initial conditions are 0. Okay, and therefore taking the z transform of this one, z transform y of n is y of z, z transform y of n minus 1 is z raised to minus 1 y of z, z raised to minus 2 y of z, and z transform x of n minus 1 is z raised to minus 1 x of z. X of n ka z transform x of z. Then you have to combine the terms of y of z and x of z, and then obtain the system transfer function, which is equal to y of z upon x of z. So y of z upon x of z is z raised to minus 1 upon this term. So this is a transfer function of the system. This is in terms of negative power series of z. You have to convert it into positive power series of z by multiplying it to z square, because here z raised to minus 2 is the highest power here. Okay, negative power, and therefore you have to multiply it by z square to numerator and denominator. Okay, so if you multiply by z square, here you are getting z square minus 4z plus 4, like this. Okay, and therefore the output of the system is y of z is equal to x of z into h of z. But what is the input you are applying to the system? Impulse input, because we require the impulse response. So input to the system is impulse, and therefore its z transform is 1, and therefore y of z is equal to h of z, x of z is 1, and this h of z is z upon z minus 2 square. This is z minus 2 square. Checking in inverse z transform, okay, the z upon z minus 2 का inverse z transform is 2 raised to n u of n, and यहाँ पे square है, इसका मतलब यहाँ पे n multiplication में आएगा. Okay, so therefore here n into 2 raised to n u of n, it's the inverse z transform, this one, and this is we call the impulse response of the system described by this difference equation. Okay, thank you.